Begin. My name is Nadeemul Haq. This is the PIDE, Pakistan Institute of Development Economics. We are here to discuss our favorite subject, Internet for all. We in Pakistan consider Internet to be a luxury. We are trying our best to restrict the use of Internet. The government is even taxing the use of Internet. It's very sad. The government is even taxing the what do you call it? The devices, so that we can't get devices. So we are turning to our friends in Silicon Valley to see अगर कि वो हमें बता सकते हैं कि हम internet for all कैसे करें. What is it that we should do to get internet for all? So I am very happy to say कि मुझे ये मेरे दोस्तों ने वहाँ से मतलब हमें ज्वाइन किया है कैलिफोर्निया से और ये हमें हेल्प करेंगे. ये माशाल्लाह सब सिलिकॉन वैली में बड़े वेल नोन वेल टू डू लोग हैं, अमीर लोग भी हैं और वैसे भी पता नहीं इनके पाकिस्तान में दिल का दर्द है कि नहीं, पर देख लेते हैं आज. लेट्स सी क्या हमें बताते हैं. तो हमारे साथ हैं फैसल हक जो कि माशाल्लाह unfortunately he's joining us but he's got bronchitis, तो पता नहीं कितना बोलेगा. Then we got Mr. Khalid Riaz, Network Options for Universal Internet. My God, that's lovely. That's what we need, Khalid sir. Then we got Dr. Suhail Chughtais, deploying telemedicine in Pakistan. Okay, that's another interesting one. Then you got using 5G as the last mile option. Okay, great. Then which is Ahmed Shahid. Then you got Imran Qureshi, who's going to do virtual education in Pakistan. Okay, this is wonderful. So guys, I will not intervene. I will ask you guys to take over. So who is going to go first? Faisal, you or Khalid Riaz? Raza sir.
Khalid go first.
Khalid saab, go. Khalid saab, go. Over to you.
Thank you very much. So guys, a little bit about my background. I've been working with the internet since 1995, the building of the internet backbone. And then for the past 25 plus years building most of the wide area, we introduced a technology called SD-WAN in 2012. We were the first company that introduced the concept of software-defined wide area network. It was a $0 industry in 2012. As of now, Gartner predictions, as of 2021, it's an $8 billion industry. It is actually building the next generation of the wide area. And I want to give a little context to this discussion. What have we learned through our history lessons and why? And I think a lot of my observations, especially when I go to Pakistan, Middle East, and one of the things that deeply bothers me when I see that regulatory bodies are very restrictive over voice over IP. So that clearly shows you the mindset that the people who are actually running the show come from a very telephony-centric mindset that we need to regulate this system. We need to get as much revenue out of traditional technologies as I could. The beauty of the internet model was that the power needs to go to the edge or the creator of an idea, of an application, of a service. And unless you stay in the mindset of telephony, one of the things that you pointed out that we are actually taxing the internet usage, we're taxing the edge use. That clearly indicates that the mindset, people who are actually regulating, people who are actually driving the regulations on that in that part of the world are still people who come from a very traditional telco mindset. And part of this is seen here in the US as well, but that clear sign that the technologies like voice over IP are not permitted is a very sad sign. And still, till last couple of years when I used to visit Middle East and Pakistan, I would, anytime I would do a VPN, I would see voice over IP not a permitted technology, which is very unfortunate. Although at least in Pakistan, आपके पास अभी WhatsApp वगैरह को आपने इतना restrict नहीं करते, but in UAE and those type of countries, they even restrict WhatsApp calls. How unfortunate is that? That clearly indicates that they haven't figured out the new revenue models that internet has provided. And where we're going to it's tremendous opportunity. And the argument for universal internet becomes a lot more interesting because the next decade is all about data monetization. How would I have the ability to monetize any data that I might be creating, somebody might be interested in consuming? And that is even going to take the universality of internet to the next level. So based on this, what I wanted to highlight that this is something that it's Joseph Sumter, who was an economist in the 30s, said a very interesting observation. I love this quote, is that capitalism is creative destruction, in which the old economic order is perpetually cast off to make room for the new sources of wealth creation. If you look at what the opportunity happened in the last couple of decades, that the Facebooks, the Googles, the content delivery systems, if you look at all these guys, they're content delivery systems that you're able to consume as a consumer for any content that has been created. The future is all about edge compute. There is tremendous amount of investment happening in that area. And that is why the universality of internet becomes even much more interesting. And this is where my second argument comes, is the incumbents face the innovator's dilemma. If I'm looking at even existing companies, the big companies that you see, the big giants today, they are very nervous when you talk to some of the senior leaderships in those companies, that they see disruption coming their way. And the reason it's so difficult for the firms, I would quote my previous firm I just left recently, from Cisco's perspective, the hardware is so deep in their DNA, and we're heading towards a service economy. So what do? This whole disruptive innovation that is coming in my way, which is very disruptive to my business processes. So how do I actually go and compete in a market which is shifting away from what I have sold successfully, and it's going towards a very disruptive economic model towards my basic business model? That whole idea is becoming a very, very interesting, as we're seeing the companies emerging and a lot of existing traditional companies really struggling to figure out their next evolution of their business models. So coming back to the history lesson, that what we saw, and this is where I get very disturbed when I look at some of the things that I see especially in our part of the world, that internet ko agar aap dekhen in the last, I would say, decade or so, internet has purely become a content delivery network. The Facebooks, the Googles, the Netflixes. What is happening to the internet now? It's pivoting towards its original design, which was peer-to-peer. Anybody can communicate to anybody at a massive scale. And this is what I think, and I think the next one of the speakers, which I am very looking forward to listening to, 5G last mile. 5G last mile gives you one very big opportunity of high bandwidth connectivity at the edge, which obviously will drive more enablement for peer-to-peer communication, because that is where the Internet of Things, the next decade of internet usage, is not the consumers, because we always hear that there will be 6 billion users, but there will be 30 billion IoTs. That IoT that is sitting at a remote location is a data sourcing device. So the data gravity is shifting. If you look at the current data gravity on the internet, it is centralized. The tomorrow data gravity of internet is distributed. The edge is the source of the data. And if edge is the source of the data, if the data is created at some location, it will be consumed and it is monetizable. As they say, the data is the next oil. So the internet, what has transformed into a hub and spoke model, needs to go back to a pass-through medium of peer-to-peer communication. Now, the next challenge that is being faced, and I'm in the midst of it, we are actually focusing this area, is one of the assets of the internet was the reliable delivery. So you didn't have to do much in the middle because it was a pass-through, unreliable medium, where network as a service is the biggest focus for all the big companies at this point. If you look at Amazon creating something called Outpost, Cisco offering service called network as a service, and they're trying to say, okay, if we have to take internet to this medicinal usage, if it's delivering industrial grade reliability, if it's going to consume this edge compute in the most optimal way, which might be carrying a compliance data, we have to look at how to bring internet to some sort of better reliability than it has today. Then the second phase of it is again, going back to when we created the whole architecture of internet and the way we have actually pivoted in the last few decades, it's the universal addressing model. Internet today doesn't have the universal addressing model. So how do we go back towards the transaction of the internet, which the bigger usage of the internet would be an enterprise than the consumers? Then how do we build that universal addressing model? And another important criticality why internet succeeded to the orders of magnitude versus traditional telephony network, it was not a network-centric approach. The network was just transparent. So internet as a whole required a very minimal design and functionality. The next generation internet, which is actually in the serious thoughts and discussions at that point, that how do you give internet the same flexibility that it had, but bring some reliability into it, keep internet as whole and in its minimum design, but some guaranteed delivery of services, because tomorrow's users of the internet are much more guaranteed delivery users. Internet of Things are much more guaranteed delivery. And before I exited Cisco, I was working with some of Cisco's prominent medical equipment manufacturers. COVID exposed some very, very interesting thing in the healthcare industry. And they are now saying, okay, the elective surgeries, which is the biggest revenue generation for the hospital systems, got very seriously disrupted during COVID. And that is one of the biggest revenue generators for hospital systems. So how do we actually detach those from bigger hospital and take them into ambulatory care clinics with the same reliability? Because there is a lot of logistical issues there. The scale changes when although people will say it's happening, but not at the scale and the magnitude it needs to happen. So a lot of those guys who are in the healthcare manufacturing industry are saying, look, what we need to do is to create a system of that reliable connectivity that this medical services, especially these elective surgeries, need to go out much, much more distributed than what they are today. So from that perspective, how do we actually get this universal medium ready for the next generation services? As I earlier said, that if you look at today's internet usage is pretty much consumer consuming services. Even software as a service, the Office 365, the Salesforce, they are all available on an unreliable public internet. Where we're heading is the next generation services. You can't afford the unreliability of internet if remote surgery has to take on. You can't trust the unreliable internet if the digital twin. So for those of us who don't have the idea of what manufacturing is heading towards a concept called digital twin. So whatever I have on my factory floor has an absolute replica through these IoTs in a virtual world. So if I have an issue in any location on my manufacturer floor, I can do predictive maintenance, and I will be able to fix and improve and do that predictive maintenance remotely with a very minimal set of unskilled labor required to change that part rather than the understanding of the whole system. This will have such revolutionary effects to these oil fields, remote drilling systems, factory floors. So these type of things that you see that are actually would be the bigger users of the internet of tomorrow requires a lot more reliability than what we are used to today on the internet, because I can't guarantee end-to-end service over the internet because I don't control the end service point. I'm just making sure that it gets there, but I don't guarantee delivery. But if I'm to get into the next generation of the internet, where the reliability becomes a very key factor, because if I am doing any remote surgery or I'm doing any remote fixing, then these elements have to become a lot more reliable. So internet of tomorrow is very different than internet of today. Because one of the things that you hear consistently is this digitization. So digitization is really an existential threat to those who do not transform. And it's very, very much on the minds of the CIOs and the CEOs you're talking to. Companies are heavily investing in edge compute and figuring out how we actually get you to that digitization where you, starting with companies, tomorrow individuals will be able to monetize that data. If I am a source of data, I should be able to monetize it. And from that perspective, people will pay an individual who is interested in monetizing their data. But today, this model is being started by the enterprises that if I have a branch of tomorrow and any source of data, any video analytics, any element I have in that branch location, which can generate data, somebody is interested in acquiring it. And if I do not transform that whole thing into monetization of my data, it will affect my profitability. But the biggest inhibitor of that next generation of the internet is the network, the internet itself. It's one of the biggest inhibitors because the Googles and the Facebooks and the Apples transformed internet into a pure content delivery. The content delivery model of internet will not sustain in the next 5 years. It is the edge compute, which is the biggest driver of the next generation of the internet. And the biggest barrier is twofold. One fold is the bandwidth, which I think the 5G guys will solve. So I will have that much capacity to be able to deliver services direct edge to edge. The second, it's the internet architecture itself, which is seriously looked at by a lot of companies at this point, that how do we transform it and get it ready for the next wave, which again is the very exciting time for us. But if I look at any presentation today, that any business leader who talks about their transformation, they were all talking about in the last 4 or 5 years is the cloud first. But that is not the future. If you look at talk to any business leader today, that they will say cloud first, but not always. And this is where the couple of things which I think are very interesting from that perspective. If I have data, and I might have regulatory data, that GDPR, for instance, if the data is generated for the consumer in the healthcare side, that cannot be exported outside of my country. So then I have to find places and resources. And this is where I think countries like Pakistan have an interesting opportunity, that you can start creating data warehouses. Because if you look at what Microsoft has announced, because they're trying to go closer to the edge, Microsoft would be investing in small data centers, about hundreds large to small data centers a year for the next 5 years. And what is the biggest asset for these data center providers who want to get into the business? Low cost power, which unfortunately is a problem for Pakistan. But I think there are opportunities if we start taking these elements towards solar energy and says, we will provide you low cost power and cooling. Then there is a lot of interest from a lot of players who are trying to go closer to the edge compute, to the distributed compute, and says, if I can get low power, I would be able to create a lot of distributed cloud connectivities, because cloud is going to get more and more decoupled and distributed.
Khalid sahab, zara jaldi kar le, we got a lot of speakers.
Okay. So who's this? Sorry?
Nadeem keh raha if you can hurry up, because we got a lot of speakers here.
Okay. So finally, the workload placement is going to be based on the usage, physical infrastructure, and your application portfolio is going to be driven by the strategy, how you deliver it, not based on where exactly the current IT is delivering. So in short, the future of the network is all about the edge, the Internet of Things. The bigger user of Internet tomorrow will be the IoT and the enterprise, not today the way we've been using as a consumer. So finally, what I would leave you with the point is your data centers are going to get completely transformed. The workload placement will drive how you generate the revenue, and think about the universality of the internet, and the access of the internet will drive your ability to deliver and monetize things, but you're not being traditionally able to. So just one last point, data is the next oil. Anybody who gives access to that data universality will be able to monetize and generate new business models. Thank you very much.
Great, Khalid sahab, very good overview. But I must point out that we are sitting in a world of 2G. The average internet in Pakistan is 2G. the average mobile user uses an outdated phone. So average speed is like maybe 8 megabits or something. So there we are. So folks, tell us, QG, Ahmed Shahid साहब, आप कह रहे हैं 5G is the last mile option. हम तो अभी 4G पे नहीं पहुंचे, तो क्या करेंगे? How should we do it? But please be brief, ताकि we can have a good discussion. Ahmed Shahid साहब.
Okay, let me share my slides. Just bear with me 1 minute.
Mm-hmm.
Okay, can everyone see my slides?
Gee, we can. Go ahead.
Okay. So, brief introduction. My name is Ahmed Shahid, and I have spent at least the past 7 years designing 5G base station equipment at one of the communication companies here in the Valley. And before this, I used to work on LTE baseband networks. So my talk is about 5G and why we need it, what benefits it brings, and how do we get it. Okay, so first, an introduction. What is 5G? The 5G is a 5th generation wireless network, and it is designed to connect users, devices, machines, and objects. This is the departure from the past. The previous networks were designed to connect cell phones, right? This network is designed to connect a lot more than cell phones. It enables Internet of Things. A few of the things it brings to the table. One thing is that it brings multi-gigabit to the end over a wireless radio network. This is also a significant departure from the past, where previous generations of networks were not able to get to this data rate. 5G provides expanded capacity in terms of bandwidth and the number of devices connected to the network. 5G provides ultra low latency. The latency part, the time it takes for data to get to the end, be processed, and acknowledgements received. 5G has put a lot of effort into reducing that latency, and there are many applications that become enabled because of this reduced latency. Then 5G provides increased reliability in terms of data transport over wireless network to enable more industrial applications. Yeah, there are things built into the 5G network to increase data reliability and delivery on time and with correctness. And lastly, 5G is more efficient usage of power. Per bit, it actually uses less power to transmit the data wirelessly than previous generation networks. Okay, moving on. So 5G is built to connect devices. The previous generation of networks mainly was focused on connecting cell phones and laptops, those things, to the internet. 5G has connectivity options for IoT devices, autonomous vehicles, virtual reality experiences. Medical devices is a big use case of 5G networks, as well as smart homes, smart cities, and utility and infrastructure monitor and control as well. Okay, 5G wireless networks. So one of the changes that has been built is that 5G is a tiered network with different frequency bands. Some of these are new and are being deployed for the first time, and they really offer different capacity and different use cases. The most important one of these is this thing called the millimeter band, or a millimeter wave band, which is a frequency range of 24 gigahertz plus. And this band is there to provide high capacity, like 10 gigabits per second of wireless connectivity. And the main use case for this band, which is revolutionary, is that this band is there to replace the wired connection today. So today, to your homes, to the offices, there's a wired internet connection. And this part of 5G attempts to replace that wire with a wireless connection, right? So this is where the biggest difference from the previous networks occurs. Then there's a 5G sub-6 gigahertz band, and this occupies frequency ranges from 2 to 6 gigahertz. And this is the primary use case for this band is, an upgraded wireless network for your cell phone class of devices, where the bandwidth provided to the user is about 1 gigabits per second, and you can do wireless communication as well as mobile high-definition video streaming, multiple streams, teleconferencing, those type of applications. And the last band of 5G is the low band, or what traditionally used to be LTE, which is the sub-2 gigahertz band, where the provided bandwidth is less than 100 megabits per second. And the use case for this band is your IoT sensors, industrial equipment, connectivity, monitoring, medical devices. What 5G brings to this in terms of modifications over the previous networks is that 5G is built to handle billions of these devices, and literally billions. As it was mentioned earlier, there are going to be 30 billion IoT devices connected. Now, 5G network addressing and scalability is designed to handle hundreds of billions of these devices. In some early use cases, it seems a little bit ridiculous, but in some early use cases, I've seen every light bulb in a facility have a 5G sensor and be controlled by a wireless control center rather than cabling within a building to control it. It seems rather ridiculous use of technology today, but tomorrow, even light bulbs will be controlled through wireless sensors and not through wires that building has to be wired up by. Okay, let's see what makes up these wireless networks. So, similar to LTE, the radio access network, or RAN as it is called, is built over a mobile core of wired IP network. This network is built with performance and bandwidth guarantees, but the core of this network is a wired IP network. On top of this is a backhaul network, which consists of base stations communicating with this mobile core network, and forming the basis of your wireless network. Connected to these base stations are your remote radio heads, where the signal is your signals are still transmitted over wires to antennas and to be distributed over the geography where these wireless signals are required. And the last step of this is the actual wireless communication between user equipment and these radio heads. This architecture is similar to LTE 4G. The equipment classification and those things don't change much from the previous network. The latencies are much shorter. The bandwidth is higher. So there's those changes, but the overall structure of the network between 5G and the previous LTE networks remains similar. Okay, diving a little bit into equipment, if you look at what makes up 5G network equipment, based on 5G network core, there are these units called the baseband units, which do packet processing for your layer 1, layer 2, layer 3 type applications, and these remote radio heads, which comprise of antennas, which transmit and receive signal from wireless devices, as well as provide all the time synchronization to these wireless devices. There is an open standard sorry, go ahead. Is there a question?
Sorry, go ahead. I'm sorry. I apologize. Go ahead.
There is an open standard that is being developed on top of 5G called 5G Open RAN. and it's an open access radio network. It's a standard where anybody can develop these radio heads and these baseband units. And it kind of becomes a plug-and-play network where any vendor or any company can deploy these things. Today, in the traditional radio access networks, this radio head, the baseband unit, the IP network is provided by one provider who charges a significant amount of premium to provide this whole connectivity. And there's about 10 or 12 providers in the world who do this. In the wireless network of the future, you can buy your control unit from one vendor, your data unit from another vendor, a radio head from a third vendor, put these together and build these networks yourself. So this is a standard. It is being standardized. It's called 5G Open RAN. Okay. Diving into some of the technical aspects of what a radio base station or a 5G base station does, we start with a radio head antenna, which has the analog electronics and the power amplifiers to go amplify these.
Can I ask you a question?
Sure,
technical
absolutely.
details so हमारे crowd को नहीं समझ आएंगी, but I want to ask you very simple.
Sure.
Can we jump to the 5G straight or we can't?
Yes, you can. There is nothing that prevents you from jumping to 5G straight.
Second question, if we can jump to 5G straight, let's say we dream of going 5G for the entire country, how much do you think it'll cost? And do we need a fiber? You said we need a fiber optic backbone. How much of a fiber optic do we need? Do we need a fiber optic across the country, or can we lever off a fiber optic network? Secondly, can we do satellites or something, or balloons as people talk about? I'm a layman, I know nothing about it.
Yeah.
So how quickly can we go to 5G?
I pulled this slide from one of the websites showing the Pakistan wireless coverage map. This was produced in 2019, so probably it's slightly outdated. But this shows the 4G and the 4G plus services available in Pakistan today. And there are spots where this is there. So Pakistan already has a wired network that's supporting this wireless network, right? So I believe the fundamentals of this network already exist. And there are somewhat 6 providers there. This equipment has to be upgraded to support 5G wireless standards as well as the 5G bandwidths, but I believe the basis for this equipment is already there. Now, in terms of what it costs to do this, if you look at our neighbors, I actually had a slide on our neighbors. Our neighbors' country, our good friends to the east, did not have LTE, and one person, literally one person, decided that he was going to connect all of India to the internet and built a network called Reliance Jio. The second thing that this person did was he made the data portion of this network free for anybody to connect, just charged for voice calls. And he literally connected 1 billion people to the internet starting 2015. He was not a cell phone provider. There were 5 other providers there. He financed and became India's biggest data transport person and internet connectivity person. And by the way, he did it to install an LTE network, not a 5G network. Before that, India did not have a LTE network. And now they're in the process of upgrading this network to 5G. And so in terms of what it costs and how it's required, this can be taken on by a private enterprise. I've actually illustrated a use case. The equipment, the radio heads, all of this is deployable. The capital investment is significant, but it's something that our neighbors have demonstrated that can be done by one industrialist.
And this geo network is financially successful, or is it subsidized?
It is the biggest financial success in India's wireless thing. He's put a lot of other cell phone vendors out of business. And
So
he's got investment after, because he's the India's biggest network now. Google and Facebook have invested in this thing. So if you Google Reliance Jio, you'll see the details of what this is. What has
now,
transpired since 2015.
in terms of regulatory permission, because in our country, the biggest problem is we love regulation and we don't want things to develop because we're very suspicious of each other. So in terms of regulations, what does the government need to do to allow a Pakistan Jio to happen?
Well, they need to first, there's the 5G spectrum auction. So who owns 5G spectrum, who's allowed to transmit and receive on it. That's 5G is a new spectrum. As I mentioned, there's these new radio bands, the 6 gigahertz radio band and the 24 gigahertz radio band. So the government does need to get involved here, right? These bands are auctioned and companies buy these radio bands. So there is government involvement here to set up 5G network in first specifying these bands, specifying where people are allowed to transmit, receive, and who gets access to these bands. So from that perspective.
Tell me, the one thing that we love to do is what I've heard from other cell phone providers and bandwidth providers is that the government wants to extract a huge price from the auction, and B is too stingy in auctioning the spectrum. This auction very slim parts of the spectrum, even though I believe saving the spectrum is not like putting it in the bank account. So how do you see that's correct, or is that not correct?
So there has to be some policy initiatives at the government to make the spectrum accessible.
So if I may jump in here, I think Ahmed, like Khalid pointed out, right? We are too focused on revenue from voice and not enough. I think the point of this presentation, the whole series of presentations, is that what can happen with the internet if you had a free internet for all. The savings that we would do in our other infrastructure, like medical and educational, would be enormous and would probably help pay for it. The investment is significant to build an internet for all. There's no question.
And
5G, right? So
that's absolutely correct. And the example across just for our neighbors is literally one guy took it upon himself to embark on this mission to have internet for all and actually achieve that success, right? It wasn't a big collection of people. It was one guy's objective to connect 1 billion people to the internet in one of the poorest countries in the world. And he was successful on it.
Let me ask you another dumb question. If the government keeps hoarding spectrum and does not give it, will Elon Musk, who's putting satellites around the world, will Elon Musk trump the government and allow us universal access?
I haven't followed up a lot on satellite communications, but from what I have heard, the satellites are communicating as access points for these wireless networks. I don't know if the government is controlling that or not, or can you bypass the government? Or if people attempt to bypass the government, will the government actually step in and curtail this activity? But at least from some of this, I've heard of or I've read about wireless networks, the last mile delivery networks actually getting connections from these satellite networks. The network diagram that I showed, this wired IP network, this portion actually gets its feed from wireless satellites. So whether that's
I think Elon Musk and others like him are not interested in Pakistan. They're focused on far bigger opportunities. And the harder we make it for them to participate, the less interested they're going to be. So, government really has to, step out of the way and let the entrepreneurs do their job
Faisal, I find something very interesting that Shahid Saab said. For these government guys to get educated, and says, look, why Facebook and Google jumped quickly and started to partner with Reliance? Because for them, the universal access is key, and then they can help monetize that access. So
Absolutely.
this is very key that other players will jump into Pakistan if they see there is universal access.
Right. And Google and Facebook invested billions of dollars because, in one investment, they got access to 1 billion customers, right? It wasn't the Reliance guys peddling their stuff saying that, hey, come invest in us. It was the other way around. The people came to them and said, look, you've got 1 billion users and we want some of these users as customers. So please, we're begging you to let us invest in this.
So look, Ahmed, Faisal, Khalid, you guys are sitting there. Tell me, Pakistan is 220 million people. We are not small by any stretch of imagination. Why can't we lever our population?
It's a government problem.
So
government problem, simple.
Government allows access. All of Pakistan can be covered with internet access, a very high-speed internet access. It doesn't have to be 5G from the start. It can be LTE. LTE will get you a lot of this thing. 5G is eventually where things will get to, but you don't have to start at 5G.
Mm-hmm. But I think to add to Ahmed's point, either way, we're looking at significant investment. If you can invest in 4G or 5G, it's a significant investment. You can make that investment. Let's start with 5G anyway.
Yeah.
And not too. And second thing is government. Pakistan's internet and communications infrastructure is too heavily regulated. It has to be deregulated for it to make sense for entrepreneurs or commercial enterprises to jump in and start helping, which I think is probably the best way to go. But I think for that, the government needs to realize that the revenue it's collecting is minuscule compared to the tax revenue they collect from future enterprises that come into play, right? So I think that's the educational part that needs to happen.
Yeah.
Great. Good job. So let me bring in Suhail Chughtai as well, telemedicine. Suhail Saab, are you going to be able to do telemedicine this kind of internet? And how do you feel about what's happening?
Suhail, you're on. Yeah.
Ji Suhail Saab, are you there?
Sure, you're on mute.
Suhail Saab, unmute yourself, please.
Can you hear me now?
We can. Go ahead.
I've just shared a slide as well. Telemedicine is one of the portals where we can really bring the utility as an integral part of the service. Health is not an option, it's a necessity. And to equalize the physician density, we can use telemedicine, which in fact is the heavy use of internet. And I was going to share with you the story of Pakistan's internet and telemedicine from a medical perspective, that how did we manage despite the difficulties we faced in the last 3 years. So may I go ahead? Hi, can you hear me?
Go ahead, please.
Thank you. So, sorry, there's a bit of background. Can I go ahead now?
So, sir, go ahead. Nobody's talking. Go ahead.
Thank you. So, just to introduce the context, I'm being an orthopedic surgeon for really 30 years now in Pakistan, Saudi Arabia, and for the last 20 years in England. And at the same time, for the last 20 years, I've been heavily involved in medical IT, being a Microsoft certified specialist and then masters in telemedicine lately. My work has been basically solving healthcare problems through technology, at the same time certifying and training doctors on medical IT. And that is where the last 20 years of my life, along with my clinical practice, has been spent. So just allow me to take you forward. Now, this is what I'm going to share with you, nothing theoretical. I'm going to share with you what we did in Pakistan. We did direct telemedicine, where patients were able to connect to the doctor from a website. We did the assisted telemedicine, patients going to a lab, connecting to a doctor from a technician's laptop. Then we gave devices to the patients so that they can do the automated care, especially those who were discharged from private hospitals after major surgery cases. Then we started workplace-based telemedicine in smaller institutions. This is under pilot at the moment. In one of the school chains, we are doing pilot for the school telemedicine. So we can provide a GP for all the school hours online. And at the same time, one of the hotels has agreed to participate in telemedicine for the travelers. And then this is the latest project. We are designing a van, which is a mobile polyclinic, which has all the necessary gadgetry, which is required to do 9 or 10 specialties. For example, ENT, for example, dermatology, cardiology, gynecology, pediatrics, and rheumatology, endocrinology. All these gadgetries would be here so that this is a mobile polyclinic, specialist clinic service. And at the same time, we also have a project where we are putting small clinics in hospitals where patients can come and see the specialists who are not in the hospital at the same time. So this is the design of the van, and similar to, it's not exactly the same design, but it's quite close to that. And this is the design of the room where the patient will come and the technician will connect this patient to this doctor. So basically what we achieved is an increasingly efficient use of resources. Like computers were lying vacant, internet was not being used properly. Then we were able to provide the medical care much earlier. And we were able to penetrate small towns and villages of Chichavatni, Pakpatan. We saved the cost because the patient did not have to travel, and the doctor and the specialist was not required to be brought to a village. We also increased the options available to the patient, like a child specialist is available without traveling. And then we avoid unnecessary transportation, which made that environment greener as well. So I want to quote a small, my next 2 slides are from Dr. Bilal, Professor Dr. Bilal, my colleague from USA. He presented a study, and I want to quote these two slides from his study, which show the efficacy of telemedicine, that how virtual visits can shift the care paradigm. Now, this particular box shows when the care was done door-to-door doctor visit. A lot of time was lost in transportation and waiting. And that is significant. I'm really thankful to Bilal for providing these slides. And look at the time involved in actual care and just go to televisits. The time spent with the patient goes up 72%. And the time spent in connecting and all those ifs and buts being sorted was 28%. So thank you, Bilal, for sharing this study. And you can see that the gray line shows where the telemedicine or telecalls were used, and the red bar shows the actual physical care. And you can see that this is a pretty prominent structure where you index the better improvement or made a real difference to the patient care. Coming back to my own slides.
Suhail, if I can interject, so this is Bilal. So this is a study that I did on Parkinson's patients, and as you know, Parkinsonian patients, it's very hard for them to move, to do anything really. And, they're ripe for telemedicine intervention. So they just we do everything at their point of origin. And as Suhail just showed to you, makes a huge difference. Suhail, I was wondering if you can talk a bit about how you managed to do it on a 2G technology rather than the 5G network and all that we're talking about, and how do we get in touch with patients at the point of contact with what we have in Pakistan, the minimal infrastructure that we have in Pakistan? I think
this is exactly what, Bilal, I'm very interested to show, that how did we manage the bottleneck of internet. But can I just show a bit of a context that in UK, you can see that 45% reduction of mortality rates. I just want to briefly go to that particular slide which Bilal referred. But you can see the 14% reduction of elective admissions. So telemedicine has a strong case. And I believe that medical colleges will fail to deliver, despite even if we double the number, we cannot get the doctors that quickly available. Telemedicine can cover the gap. And then you can see that this is again a study in Australia, which showed that it improves the clinical governance, provides evidence-based care. This is telemedicine's advantage. Bridges the gap of rural healthcare service. This is very much our need. Improves access to modern healthcare services, otherwise not available. Reduces adverse events because we provide the treatment quickly. Gives patient an increased choice of healthcare services. This is the benefit. So now this is where I'm deducing this from what we did in Pakistan as well. Telemedicine adoption improves the cost efficiency. Now we have 500,000 patient data. we provided care to 500,000 patient data at a much lower cost. And I'm going to show you that slide in a minute. Telemedicine adoption reduces the carbon footprint. As you know, patients will not travel. Telemedicine, now this is where the whole story begins in Pakistan. Now, Pakistan is now at number 3 in recovery from COVID onslaught. Number 3 in the whole world. And many other policies helped us. Telemedicine was one of them because I helped deploy telemedicine in Pakistan with the help of government of Pakistan much earlier on the 12th of March precisely. So we were able to limit the disease transmission. We ensured the continuity of care. We regulated the disease prevalence. We knew where the corona cases were more in number. We collected data, 500,000 patients, protected healthcare workers. Doctors were dying. 512 healthcare workers died in 6 months in Pakistan. We protected patients from mutual contact in waiting rooms. And then the pathogen burden was lowered. Now, this is where what Bilal was referring to. This was the day when Imran Khan, the Prime Minister, announced the lockdown. And I was in a press conference in Lahore. That was the last day the flight was leaving Pakistan. I suggested telemedicine to be deployed in Pakistan across universities so that we can get the patients back in home, they don't travel unnecessarily. And the governor picked it up. While I was at the airport, he announced that should be the way forward. And in 2 days, we were able to set up a telemedicine helpline. One of my software I adapted. I've designed about 40 telemedicine softwares. And this is just one of the simplest one I picked up, and I adapted that, gave it to universities who set up the telemedicine hubs. And then we gave a briefing to the governor. And I also gave a briefing to the president of Pakistan, Dr. Alvi, of 536,000 patients from March to September. And we managed a wide spectrum of disease, not just COVID, many other things. But patients were worried that my child will go out for a trivial skin rash. Why not have advice from a doctor that like simple homemade remedies like ice applying on the skin. And that actually helped patients had mental peace that, yes, we were able to speak to a doctor. Even BBC picked up. BBC heard that why Pakistan is doing so well. And we had 75,000 deaths by September in UK. And Pakistan had 6,300, something like this. And BBC picked up that why Pakistan is succeeding. So they made a documentary on my software. And this is a ward round in Jinnah Hospital, which we are conducting from UK on one of my software, Tele-IC ward round. And then there were 2 or 3 feature summaries in UK. One of them is this, and then there is the BBC program, whole program on Pakistan telemedicine. Voice of America also did publication. And then I was asked to write a book on this story of Pakistan's success. So I wrote a book, and I was joined by American Telemedicine Association chairman, Professor Jay Sanders. He said, Pakistan has a story to tell the world. Pakistan is a brand to share with the world, the telemedicine brand. And you know why he said that? That is what Bilal was referring to, that you could do telemedicine even without internet. And we are struggling in the most modern country to deploy telemedicine. How did you do it? And that book actually tells you the whole story in 280 pages. I will share the link of that with you. And then the Health Minister of Punjab, Yasmin Rashid, wanted us to start telemedicine in Punjab divisional levels. There are 9 divisions of Punjab, and we wanted to connect the basic health unit, where there is no specialist, to the Tehsil headquarter or district headquarter hospital, where there is specialist, without the patient to travel. So we started telemedicine, and this is where we succeeded doing telemedicine without internet. Now, when I refer to telemedicine, I refer to video calling plus medical data transfer, live video calling with live medical data transfer and screen sharing. Now, how did we break the bottle of internet? I fragmented the technology of telemedicine, the bandwidth, into small bits, and then went through the bandwidth of 360 kilobyte available on a 3G mobile phone, and then reassembled the signal at the processor level, just like Netflix, and then connected all that data to a local node in Karachi. So the handshake time was less than 0.5 seconds with 720 pixels resolution on the screen because of regeneration of the signal. So that was the lab work we did to adapt to Pakistan's bottleneck of telemedicine internet struggles. So we were able to do that. And I'm going to show you This is Pakpatan and Chichavatni areas. And we were connecting patients in small basic health units on small Lenovo tablets. The government has provided those tablets to midwives. So we borrowed those tablets. We connected those patients to the specialist in district headquarters using 350 kilobyte per second upload speed only. That's what we did. That's on record. So how did we do it? That is the way I worked on my own software. I placed the intermediary data in advance to prevent the latency. I used the tiny push code technology to push that data rather than pushing the whole data. I pushed the code and the data was already available. Then the data fragmentation and reassembling with a minimum latency using advanced algorithms. I used the processor of the device. And then simplicity of page loading. I made the code very lean. Use the software language.
Faisal, can I interject a little? ये सब technical बातें, but I'd like to ask you two key questions. मुझे ये बताइए कि ये सारे पाकिस्तान को आपकी टेक्नोलॉजी सर्व कर सकती है, हमें 5G पे जाने की जरूरत नहीं, या 5G ज्यादा फायदा होगा? दूसरी चीज जो अभी आप कर रहे हैं चीज, ये I think it's very nice, very innovative, etc. But can you do, for example, telesurgery वगैरह जिसकी आगे जरूरत आ जाएगी? Can you move IoT with this? मुझे बताइए कि हमें, आपका क्या ख्याल है, आपके काम में कितनी ज्यादा हमें इंटरनेट फॉर ऑल और 5G की जरूरत है?
देखिए, आपके सवाल का पहला जो हिस्सा है, can we do that in Pakistan with 3G or 2G internet? If we have to, then we will do it. And that is, if there's no better option, then we have a solution already. It's not dreaming. It's actually, we've done it. But of course, that has limits. The limits are that, for example, if you want to do live ultrasound scanning, I would require at least 500 kilobytes per second upload. If you want to do live gynecological ultrasound scanning or a 4-chamber heart view, we would require at least half a megabyte per second upload. So then we can do the basic telemedicine, which can still be clinical telemedicine. But if you want to go next step up, as your next part of the question is, for example, in NICVD, the angioplasty is being done in Larkana. I provided them a software where the angioplasty in Larkana was being seen live from theater at NICVD. And the NICVD cardiologist was able to draw on the screen of the surgeon in Larkana. Now, how did that help? That minimized the opening rate of angioplasty. Every 5th or 4th angioplasty was open to cardiac bypass. So that reduced the complication rate because the senior surgeon was able to tell, "Bhai, yahan pe apna zara haath aista kar lo, yahan pe catheter change kar lo," and do what? So that was like over the shoulder inspection of surgeon.
Okay.
So that required half a megabyte. The way I do it, maximum 1 megabyte per second upload, and we will be able to do it.
But beside the question, what you just asked, so to what Nadeem said as well. So, for example, we do robotic surgeries here. So the surgeon might be sitting in Argentina and he can operate wherever. And it's with a robot. And these are very highly technical surgeries. And you cannot do them unless you have either broadband or 5G or something. So we have limitations. So what Suhail is saying, we can do these things, but if we have 5G, it opens up a whole new spectrum. So really, to say that we don't need it, that would be wrong to say.
No, I'm not saying that. What I'm saying is that there are limits. If we have no option, I'm doing it because we have no option. But if I have better option, I will put a better software there.
If I may just inject here, right? I think what Suhail Saab is saying and Bilal is saying is that they can adapt in some limited version of telemedicine with the current infrastructure, but obviously they can do a lot more if we had more bandwidth.
Yeah,
right?
Absolutely.
And again, I want to add, it's a part of a journey. I'm not saying it's a destination. It's part of a journey.
Suhail Saab, I fully agree with you and I compliment you on what you've done, all of you in fact. My question is कि हम जो पाकिस्तान में रहते हैं और मैं माशाल्लाह जिस एज पे हूँ, मैं कोई जवान आदमी नहीं हूँ, मुझे कोई पता नहीं कब मेडिसिन की जरूरत पड़ जाए, तो आपकी जो इनोवेशन है बहुत जरूरी है, बहुत इंपॉर्टेंट है. What I'm interested in is, अब हमारे एजुकेशन पे भी कि ये जो हमारी पॉलिसी है, हम सड़कें बनाने पे तो बहुत तेज है, हमें सड़कें बनाने का इतना शौक है. We are living in the 19th century, maybe 20th century. हमें सड़कें ऐसे बन रही हैं पाकिस्तान में जैसे देयर इज नो टुमारो, फ्लाईओवर सब कुछ बन रहे हैं, पर हम इंटरनेट बनाने पे बहुत स्लो हैं और इंटरनेट पे हम स्पेक्ट्रम ऑप्शन ये वो कर रहे हैं। तो मैं आप लोगों को पूछना चाहता हूँ, सड़कें बनानी जरूरी है या इंटरनेट बनाना जरूरी है?
If I may answer quickly, Dr. Faisal, before you answer, I think there's one sentence that I want to say to you. We need to realize the era of brick and mortar is over. We are now in an era of virtual, economies where everything is done over the internet, much more efficiently and much faster and higher quality of service. The sooner we realize that, the faster we will get on into the next stage of development. If you're stuck in the brick and mortar phase, we'll unfortunately never get out of it. And investing in roads shows that we still think that, we believe brick and mortar is the way to go. Unfortunately, like Khalid said, like Dr. Chughtai showing, like Ahmed showed, like Imran is going to show, brick and mortar is, the era of that is over. COVID showed us that. And there's an increasing trend towards virtual-based services. So I think, we cannot, Pakistan must adapt and must understand that we have to move away from these policies, right?
No, but can I also add that we are starting teaching and certifying doctors in telemedicine in Pakistan. Not only just giving them the software, but also the driving license to run the car. And that is a major shift. That is going to bring the culture of telemedicine.
Great. Wonderful. Wonderful.
One piece of information from some countries who've actually built 5G networks. One simple technology deployment method on highways. आपने mention किया था कि हम सड़कें बना रहे हैं. Highways पर जो lights के खंबे होते हैं, there is a 5G transmitter and receiver built into every single one of those in some countries. So that's how they're actually building their 5G network. Every light pole has a 5G receiver and transmitter built into it to distribute the network to where the light goes, right? So across highways,
does that obviate the need for fiber optic? क्योंकि हमारा सबसे बड़ा problem fiber optic है इस वक्त, क्योंकि हम उसको फैलाने में बहुत slow है. How much fiber optic do we need, or can we limit it to what we have?
5G will enable you to do wireless backhaul. That is part of the network. So you can communicate even with those 5G transmitters over a wireless backhaul network. However, that's not even deployed very extensively right now. The rest of the world doesn't have a laying fiber problem as big as Pakistan does, I guess.
No, but
हमारा problem ये है, हम लोग सब चाहते हैं कि मेरे घर के पास फाइबर नेटवर्क अगर निकले तो मैं उसका कोई रेंट लूं, कोई पैसे लूं, और हुकूमत चाहती है 10-15-50 परमिशन है फाइबर ऑप्टिक्स लगाने की.
But then that is a question, Shahid sir, for you. Well, the biggest problem for fiber laying out is last mile, but you can eliminate that through 5G. Then beyond that, that is not as difficult, because America maybe biggest push is happening with this Biden stimulus is around last mile 5G. I think Pakistan has enough fiber layout beyond last mile. It's the last mile question which 5G solves. So I don't know why the fiber problem exists, because fiber starts from the backhaul at that point, not the last mile. Last mile fiber is a problem.
Great. Okay, ji, let's turn to education. Imran Qureshi sir.
Assalamu alaikum ji.
Ji.
Can everybody hear me?
Ji, Imran sir.
Okay. Thank you very much. I will not be able to share or move my slides, so if somebody can just load my slides and I can talk through them. I'm in south of Portugal right now, and
so my God, you retired or something?
I am kind of retired with my family. No, I'm just joking.
Good job, yaar. South of Portugal, मुझे भी ले जाएं वहाँ यार. ठीक है.
It's a very nice place. It's a very nice place, and I highly encourage everybody to at least visit this place. It seemed very similar to Southern California or Central California. The terrain is almost the same. So, and weather is always very nice over here, and people are excellent.
Lovely.
So, moving forward, let me give you a brief background of myself. I started my career with Ford Motor Company deploying Cisco routers. And then I moved to Cisco and spent 25 years with Cisco in different capacities. More or less, I was into enablement, sales enablement, technology enablement, partner enablement. So I basically delivered all these trainings through virtual technologies. We, Cisco, and when I say we, Cisco bought WebEx back in 1999. And since 1999, Cisco has been successfully delivering virtual education programs over the internet. So that's a little bit of my background. So next slide, if you can. Thank you. So I just wanted to basically paint a picture of where we are in terms of technology and where the technology has been adopted within Pakistan. So I would say the spectrum of technology adoption is between the typewriter and the personal computer, or probably a little bit ahead, because, you know, if you look at people who are using the computers, these are people who are basically under 25 years old. Anybody who is over 25 years old is not very well versed in the usage of personal computers or the internet. So I would say the spectrum is basically in the typewriter and personal computers, or a little bit ahead. But the usage of internet, when we say there are so many internet users within Pakistan, it is definitely not true, because what happened was in Pakistan, the landlines got converted to mobile phones, and mobile phones are basically being enabled through the internet. And that's what basically most of the statistics say. It is basically the data that moves the internet, or internet moves the data. It is vice versa. And that is basically what is driving the adoption of internet all over the world, and not the case in Pakistan. And virtual education basically brings a lot of data on the network. It basically brings a lot of data users on the network. And that's where the rubber meets the road. Hello, G. Can you hear me?
Go ahead. We can hear you. We can hear you fine.
Okay, so that's where the rubber meets the road. So there are two different phases of internet enablement, or internet adoption, where the World Wide Web and the digital economy that you are talking about, what Khalid talked about, what Suhail Saab talked about, what Ahmed Shah talked about, you know, all these people talked about are basically the foundations for building the digital economy. And these foundations are basically what will move the data in terabytes, in gigabytes, in all these areas. And that is where we need to go. And, you know, virtual education is something that will drive a lot of data onto the internet. So the next slide. So what is virtual education? Next slide. So in essence, virtual education is where a teacher is teaching a student primarily on an online basis or through the internet. The education is not just basically driven through the teacher, but it's driven through the content also, and how the content is delivered. And the content is basically built around an educational ecosystem, which includes content delivery, the evaluations the students go through, the assessments, the enrollment. All these things come together, and as a whole package, this virtual education systems are delivered over the internet. And just to basically paint a picture, all these systems are already available in the on the internet. You know, there are learning management systems that are available online. There are enrollment systems that are built online. So all these things are already available that would basically make a school use these functions to deliver virtual education. So what are the instruction models that are widely deployed? The first one is basically an independent self-paced study where you and I can go in and look at a coursework and say, hey, I'll be able to, get this thing done in 3 months, 4 months using our own pace. And the second is basically live interactive classes or per se recorded classes that one can take later on or view later on and basically follow those classes and take the exams and basically complete the coursework. And the class size ranges widely vary from a small group to hundreds of students. And this Go ahead, G.
Ji, go ahead. Who's speaking? Imran sahab bole.
Ji, I'm just going. So the massive open online coursework or courses is the terminology that has been used and has been successfully deployed by these very, I would say, successful companies called Coursera, Udemy. All these companies are developing these coursework that people can follow, and they're offering certificate courses. So next slide, please. So from a virtual education perspective, what we have learned is that, virtual education enhances the research skills, the digital skills, and digital skills are very important where you are teaching somebody how to use the computer, how to basically interact with somebody over the internet, and basically to adopt new environments. And this is a skill that is needed in the 21st century where you are going from environment to environment, office to office. And we can basically say to people, okay, this is how things will be done in a different environment, and adoption in a different environment becomes pretty easy, or I would say it becomes trivial when you are delivering things online. So the learning capabilities also come into play where a user or a student. I will go ahead and do this.
Go ahead.
Okay, so the three aspects from a student perspective is the self-paced, the virtual instructor-led, and the hybrid environments. These are basically what everybody's looking at from a value perspective. How can somebody basically learn from their individual learning process? And, I will basically go ahead and conclude with the next slide. And I will just, this history of virtual education. This is the history of Stanford Instructional Television Network. It got started in 1969, and it basically solved a problem of bringing graduate students who were living off campus or who would basically travel a lot of distance. And they used the technology. The technology that they used was basically radio frequency technologies or microwave technology in those days to cover 50 miles of instruction that was sent across. And they built a very, I would say a very fundamental kind of a system that delivered the content, and slowly the content basically got adopted by a lot of corporate environments. And that's how the whole virtual education experiment got expanded and basically got into the degree programs, into the undergraduate degree programs. And if somebody can bring up the last slide, I will just finish with that last slide. The last slide, please.
Go ahead, Chughtai.
So from a Pakistan's perspective, I have been visiting Pakistan on an ongoing basis for the last couple of years. And what I have found out that the internet connectivity is coming into Karachi, and I'm based out of Karachi. So my home near Kent Station is equipped with a fiber, and fiber is coming to my home. And similarly, fiber is coming to a lot of universities. So as far as fiber is concerned, the bandwidth coming to the home and bandwidth coming to the head end, which is basically the universities or the educational institutions, is pretty sufficient. I'm not sure about other locations, but in Karachi, fiber is coming to the premise. The second thing is the cellular connectivity for a user is a little challenging, although they advertise 3G and 4G, but the bandwidth delivery is not consistent for video. It is consistent for audio, no problems whatsoever. People are able to use these cellular devices for audio communications, like we use WhatsApp and we make calls on WhatsApp. So that is basically available. So video is something that we have to basically invest into and upgrade the cellular system to enhance the bandwidth delivery. And the last thing is that the universities and the educational institutions need to be creative in offering their virtual distance learning programs or virtual education programs. And my suggestion is they should basically start using the virtual education service to offer certificate programs and programs that are non-degree programs, and they don't need to be authorized by the government. So if you can avoid the red tape and start implementing these programs, I think this will really benefit the overall community in terms of achieving higher standards of education.
Great. Thank you, Imran Sahab. Okay. Now, before I go to the audience, I've got a person who's actually involved in a edtech solution here in Pakistan. I actually got a company called Knowledge Platform, and they are educating, I think, about 100,000 students and many others online, 1,000 fintech. So can I call Mahmood to talk a little bit about...
Sure, please.
A, education, and B, how does internet affect you, Mahmood? Would 5G and having internet for all really streamline the process that you're using, Mahmood, or will it be not that beneficial? I know you're trying to bootstrap it the same way that Suhail Sahib is doing it for telemedicine, but how does internet help you? Mahmood, go ahead.
Nadeem, thank you very much. Can you hear me and see me?
Yeah, we can hear you fine. We can see you. Bilkul bole.
Okay. So I know we are running out of time. So basically, we have digitized the grades 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 math and English content, and we have digitized 6, 7, 8, 9, 10 science content, and by end of this year, we'll have done the whole science as well for grades 1 to 5. So right now we serve about 1,000 schools and 300,000 kids. And as you can see, there's quite a lot of wide distribution across the country, mostly in the north, and then of course the GT belt and the Indus River. I just wanted to speak for 2 minutes on the kind of digital and media aspect, because this is what the talk is about. So we have in Pakistan about 22.8 million kids who get no education. Then out of the 49 million or so, including 4 million in madrasas, about 27 million are in government schools, and the rest are 45% are now in private sector school. Private sector is growing at a rate of about 12%. So in about 5 years, private sector will be bigger. Now, in terms of access, education is not like Kareem, where you spend 5 minutes to order a cab. You need to have a device at a child level. Although what we do is one laptop per school to begin with, but you need at a child level, maybe about 1 million kids have a device and regular internet access. So out of the 49 million or so kids who are in the education sector, only a small 2% or so have access. TV is accessible by 40 million kids. And then there's a very interesting thing, what I call latent access, which is the TV is the white and the /white lines. And then there's latent access, which is that the parent may have a digital device, and about 24.5 million kids' parents have a device, although that doesn't necessarily translate into an EdTech opportunity, but there may be ways by linking TV and parental device for gaming, so they give it to kid for 5 minutes or doing a quick assessment, we can spread education technology much further. But this is the landscape as it stands today. Okay, that's about all I want to say.
Let me ask you a question. Would internet for all, would having 5G for everybody, would it help you scale your model?
Yes, there's as you can see from here, one big constraint is both internet and devices. So it's not just enough to have internet. If you don't have a device, it doesn't help you. So we need to massively expand devices as well, because right now, to buy a tablet, you have to pay 40% duty. So they're prohibitively expensive. And we just don't have enough devices. So we do need internet, but we also need hardware.
Okay, great. Shahid Khan Sahab. Shahid Khan Sahab is also from Silicon Valley. Shahid Sahab, please tell us.
Nadeem Sahab. Okay, I hope I'm muted. So my question is, I have two questions. Imagine there was a 13-year-old sitting with us watching this webinar. How long do you think that person would have stayed in the call? Number one. I seriously doubt more than 2 minutes, because focusing on the technology, I'm not sure. It is how do you engage the audience? So the second question is, what is the percentage completion rate on Coursera, Udemy, and other courses? And I'd love to hear the answer. I know what my answer is. Thank you, Nadeem.
Okay, great. Folks on the panel, एक second, आप लोग जरा please try and note all the questions. I'll come back to you. It'll save time. ठीक है? तो आप जरा note कर लें. I'll come back to you as I take all the questions. Amar Saab, Amar Arsalan, I think. Amar Arsalan.
Thank you, Nadeem Saab. Yeah, can you hear me? Thank you, Nadeem Saab.
Hear you fine,
so thank you. I'm associated with 5G and internet for a very long time, couple of decades. And I'd like to ask a question which probably is related to where you started the session. So you said in the beginning that it's all about internet for all. And I would like to add a statement here that how much are we concerned about global internet companies taking data from all? So it's like मैं आपको इंटरनेट दे रहा हूँ इसलिए नहीं क्योंकि आप तरक्की करें, बल्कि मैं आपको इंटरनेट इसलिए दे रहा हूँ क्योंकि मुझे आपका डेटा चाहिए. So the specific question that I have around that is that in Pakistan, what we see today, that even after decades of work and rework, we have not been able to release a data policy. And the lack of data policy means that anybody can come over here and take the data without the consent of the data generator. So data privacy, security, and residency are the factors that have not been addressed. So that's a specific question that where do you see that how can Pakistan develop without a data policy?
Good point. Okay, folks, how do you answer these two questions? Anybody wants to take it up? Go ahead.
I'll take the first one. So from Shahid Khan's perspective, yes, he's absolutely right in terms of a 13-year-old, attending this webinar. And the main thing about the internet is all about relevancy. Do you have the content which is relevant to me? And what is it about me? The way the internet was built and how it's being used is basically an infrastructure where you can go and do whatever you want. You know, if you want to go into gaming, you go and you turn on a game. If you want to communicate, you turn on email. You know, so it is all about relevancy. What do I need to do and how do I want to do that? So that is the first answer. Yes, it will be 2 minutes and it will not be more than 2 minutes. And the second part of his question was about the completion rates of Coursera and Udemy and all these course offering companies. For them, you know, the statistics are a mixed bag. The mixed bag is that if I want to go and attend or collect a certification program, the completion rates are pretty high. But at the same time, if I want to go and learn certain things that I find, you know, interesting, I may not be able to complete those until the point where it is being asked of money or basically being asked of assessments or doing all those kind of things. So yes, the statistics are pretty low if you are basically taking something for leisure, but completion rates are pretty high when it comes to getting your certificates and if they are associated with school achieving programs.
Yeah.
Can I take the data part?
Please go ahead.
So the data part is that I recently had experience of installing a project in India. Indian policy is much better defined. For example, I was required to put the data tables in India server. I could keep the software on UK server, but the data had to be in India, which is a great way because even if the supplier does not trust with the local customers, the software can still be kept on a server outside that country, but the data tables can be kept on a local server. Now, I was with a PMC, Pakistan Medical Council meeting last week with Dr. Chughtais, and they are in the process of making a policy for medical data. In fact, President Dr. Arif Alvi has announced the telemedicine policy, and data chapter is part of it. So you will be hearing, and my recommendations have gone on to that the data of patients must be in Pakistan. The software can be anywhere else. Like if it's a subscriber model, I don't want to put my software in Pakistan, for example, for the copyrights. I can keep the software in UK. The table has to be in Pakistan. And that is where the policy is coming up.
So this is Khalid. I'll actually like to address all the questions. So the first one for the 13-year-old, this webinar is not designed for non-professionals. So why would a 13-year-old attend a policy discussion? This is discussion around the policies and how we're going to go and implement policies for Pakistan. This is part of a corporate discussion. So this is not relevant for a 13-year-old. The second part of the data piece of it, we need to differentiate between a compliance data and consumer data. The Googles and the Facebooks are more about consumer data. That policy is going to be very different than the compliance data, that European GDPR angle and all the data preservation. So we need to differentiate. There has to be a policy for compliance of data, which is much more personal data versus consumer data. That should be choice of a consumer who's signing up for a Google or a Facebook and saying, okay, I'll give consent to give you the data that you can monetize.
Good point. Good point. Anybody else, Chief?
Yeah, can I just try to address that education question as well? So I think very quickly. So first of all, what we found is it's not just a question of the content being interesting. The first thing is that you have to look at existing practices. So where kids use our system a lot is in two situations. First is we are a teacher-led culture in terms of education. So you've got to start with the ground realities of Pakistan. So where there's a teacher involved in the online education process, for example, we do blended learning in classroom, we get terrific results, very high usage and so on. The second is we are an exam-based culture. So again, you get very high usage. Last 2 weeks, because exams have gone on, we've had 20,000 learners come on board in the last 2 weeks. So now what we're trying to do is use these existing realities to try to make schools and students and teachers more data-centric. We give them data, make them more accountable. So in other words, existing practice has to be leveraged because that's where what the current paradigm of education is. Then you move them towards data and accountability. We're also doing things like project-based learning, games-based learning, but that is slower in uptake because we haven't made a transition in our education paradigm. So it's a very interesting kind of migration path that we have to follow. But if we think we can just jump from one paradigm to the other, it's not going to happen. And I do believe, I agree with what a lot of people have said in the beginning, that data is really, in some respects, both the ways of bringing people from the old paradigm to the new paradigm.
Okay, folks, that's very good. But let me ask you a couple of questions before we leave. Faisal, tell me, what can we do to make internet for all? Currently, internet, like everything else in Pakistan, is an apartheid good. Like Pakistan, rich people play golf, poor people have no place to go. Rich people have clubs, poor people have no libraries. Rich people have cars, poor people can't walk on streets. So we are an apartheid society. Now the problem is the rich have internet because internet connection costs 2 to 10,000 rupees. You can't have a good connection for less than 2,000. And if you want a 50 megabyte, imagine 50 megabyte connection is 10,000 rupees. Okay. Now in the US, you can tell me how much it is.
Yeah.
Okay. So secondly, no, hang on. Secondly, the issue is we have to go online because of COVID. Yes. The poor kid who can't afford a 2,000 rupee connection, who can't afford an 8,000 rupee connection, is handicapped. The LUMS kid obviously has everything. So the question is, we are deepening the divide of inequality. So do you agree with me that internet is now a necessity far greater than cars? Would you agree with me that we should tell our leaders that internet for all is important? And now, how do we get internet for all? What is the cost? Faisal, go ahead.
Yes, okay, I think so. So a lot of questions there, but let me say one thing, right? I think first thing is we need to change our regulatory or policy-making mindset. Internet is not the source of revenue, but it's a source for growth of the economy, right? And as long as we treat it as a revenue source and we heavily regulate it, we're going to be stifling in digital economy. We will not be getting there. Secondly, the cost is substantial to go to internet for all. I don't think anybody's making light of that. The way we can pay for it is by reducing our investment in other infrastructure heavy areas such as education and medicine, where we can rely on telemedicine, virtual education to extend our range and extend our reach and make it far more efficient. We have to some extent, understand that that investment is going to lead us to savings in other infrastructure areas. And secondly, like Khalid said, data is the future oil, right? Is oil of the future, and we have to get in line into that and on that path. And internet is the way to get there. The cost we're looking at roughly, for just a 5G portion of it is probably looking at about a few thousand base stations additional that we need to add. And then if you want to go ultra wideband, there's a lot more that needs to be added. So it's in the billions of dollars. It's not cheap. Nobody's underestimating that. But I think what we have to realize is, do we stay in this vicious cycle of we keep taxing our internet, keep taxing communication, keep regulating it, and keep stifling the growth, or do we at least give hope and let the entrepreneurs, let the industry take over and drive the internet bandwidth, let them invest in it, and deregulate, and let the people move it forward. I think once you deregulate, you get investment from outside. You can make it accessible to all and make it cheaper for everybody. There's still going to be some discrepancy, but hopefully, as we get more investment, the better off we will be. But I think ultimately, I'm convinced that for Pakistan's economy to grow and to get better, we have to move to digital economy, and we have to. Internet is the bloodline. Is the bloodline for all of our future growth. And if we don't control that now and don't manage it well, I think we're going to be 40 more years of the same.
So can all you experts tell me can you please send me something succinct that I can present to the minister and say, look, wake up, because nobody in Pakistan wants to wake up. If India's got internet for all, I'm really scared.
Yes.
We want to fight a war with India, but they've got it. And secondly, if we are building roads and not building internet, from what you've told me, telemedicine depends on it, education depends on it, and we are still sitting in the 20th century. What do you guys think?
Yes, yes. No, I think definitely we can get you, we can get you better numbers, but I think precise numbers are going to be hard because it really depends on network design.
No, forget precise numbers.
Yeah.
Give me better numbers and give me better regulation.
We will.
And tell me what Jio is doing in India. I mean, I don't want long essays. Even if I know you people are busy. Even if you can give me a simple PowerPoint slide, maybe 5-10 slides,
yes,
just simply outlining what is the cost of a base station, how much does it need, how can we bring the price, how can you bring Mancha in to do it, or whatever the equivalent of Reliance, how can we get a Pakistani from Shahid Khan from Chicago to come and do it, how can we get the regulations such that people will do it, how can we get these people at the top to understand that this is not their business, they can't make these policies. Is that something you guys can do?
We can help certainly with the cost.
Khalid sir?
Khalid?
Cost as well as regulation. Yeah, regulation बताएं क्या हम गलत कर रहे हैं? India क्या कर रहा है अच्छा जो हम गलत कर रहे हैं? क्या चक्कर? Why are we selling spectrum so expensive? 3 auctions हमारी हो चुकी हैं, हम cancel कर चुके हैं. ठीक है जी. Secondly, do we need to have an auction of the spectrum? या can the government do price sharing as we go along? For example, should the government collect upfront $3 billion, or should the government simply say, okay, guys, on every transaction, you give me 10 pesos extra?
Yeah,
come on, guys, I'm looking to you for some innovation. Khalid Saab,
yes.
Suhail Saab, बताएं.
मैं अर्ज करूं कि देखिए, there are more than 20 governments who have invested more than 30% in what they invested last year in broadband technology. That's a very clear evidence the way the world is going. Very clear evidence. Number 2, if you look at the megapixels of cameras, they are constantly increasing. The RAM is constantly increasing. But we are stuck at 2G internet. Why are we not catching up with the pace of hardware and the technology around us? It's a clear case of expansion.
Well, साहब इसमें एक और चीज है. अब आपको पता है हमने Vivo फोन बनाना शुरू कर दिया और हमने Apple और Samsung वगैरह को महंगा कर दिया. आपका क्या ख्याल है? हमने टैबलेट पे 40% टैक्स लगा दिया है, कंप्यूटर्स पे टैक्स लगा दिया है. मैं अगले दिन हफीज सेंटर गया, वहां लंडे के कंप्यूटर पड़े हुए थे. आई लिटरली मीन लंडे के, कि वो मंगवाते हैं कंसाइनमेंट पे, वो कंप्यूटर जहां ट्रैश में फेंक दिए जाते हैं, अब यहाँ वो बेच रहे हैं 5-6 साल पुराना कंप्यूटर. हाउ डू यू सी द चांसेस ऑफ दिस कंट्री विद अ 5-10-year-old कंप्यूटर? इज दैट अ गुड थिंग टू डू और शुड वी कीप करंट? जी बताइए खालिद साहब.
कंप्यूटर से ज्यादा मेरे नजदीक सबसे इंपॉर्टेंट चीज है तो एब्सोल्युटली द लास्ट एक्सेस एंड द लास्ट माइल. जो आपके वन ऑफ द स्पीकर्स सेट के भाई एंड होस्ट डिवाइस चाहिए. एक्सेस, अगर आपके पास बैंडविड्थ स्पीड इतनी ना होती, इतनी कंपनीज, नेटफ्लिक्स वुडंट हैव बीन सक्सेसफुल. It is the access and the ability of high bandwidth connection that is driven the companies like Netflix and kill the brick and mortars like video services thing. The future, the internet gravity is shifting, the data gravity is shifting. If it's not understood, okay, data gravity, the next wave is somebody sitting at home and innovating and able to provide a service that doesn't have to be through a big corporate. अगर मेरे पास last mile bandwidth है, लास्ट माइल कनेक्टिविटी की हाई बैंडविड्थ है, मैं अपनी सर्विस बेच सकता हूं. और सॉफ्टवेयर के अंदर, सॉफ्टवेयर डेवलपमेंट में इतनी कैपेबिलिटीज हैं कि आपका बच्चा बैठ के बिकम पार्ट ऑफ अ लार्जर कॉर्पोरेट टू बिकम पार्ट ऑफ अ सॉफ्टवेयर सर्विस. बट द कनेक्टिविटी हैज टू बी देयर. जो ये जो रोड बनाने वाले पॉलिटिशियंस है ना, इनके दिमाग में ये बात नहीं आती, क्योंकि वो जो घर में बैठ के 19 साल का बच्चा सॉफ्टवेयर बनाएगा जो बाहर जाके फेसबुक को भेज देगा, इनकी पूरी हायरार्की को डिस्ट्रक्ट करेगा. एंड अगेन, वन ऑफ द लास्ट पॉइंट्स आई वांट टू मेक इज फिनिशिंग ऑफ सर्टिफिकेट. Mark Zuckerberg never finished a degree. So didn't Bill Gates. So didn't Steve Jobs. It doesn't have to have, you have to have a finished degree. You have to have the mindset of an innovator. और इनोवेटर को आपको जब तक फ्रीडम एंड कैपेबिलिटी नहीं देंगे वो इनोवेट नहीं कर सकता। आपने उसके पाथ में बैरियर्स लगाए हुए। 20-20 साल के बच्चे यहाँ इनोवेट इसलिए कर लेते हैं। हाउ डू यू क्रिएट मार्क ज़करबर्ग? बिकॉज दे हैव एक्सेस टू इंफॉर्मेशन एंड दे हैव इमेजिनेशन, और इमेजिनेशन के लिए आपको यूनिवर्सल एक्सेस कैपेबिलिटी चाहिए। यू आर स्टॉपिंग पीपल फ्रॉम इनोवेटिंग बाय नॉट गिविंग देम द एबिलिटी एंड द टूल्स दे नीड टू इनोवेट।
Great job, folks. I'm so thankful to you. I deeply appreciate your giving back to Pakistan. आपने हमें बहुत सिखाया है. I deeply appreciate that. Now, Faisal, I need from you this little last piece, whatever you like, notes or something. You don't have to write essays. I know you guys are busy, but खुदा के वास्ते अपना सिर जोड़ के मुझे 2-3 सवाल का जवाब देते. रफ कॉस्ट कितना आएगा? नंबर 2, क्या डीरेगुलेट में करना चाहिए, किस हद तक डीरेगुलेट करना चाहिए, जियो ने क्या किया, उससे हम क्या सीख सकते हैं. और congratulations to people who have done telemedicine, online education, etc. And congratulations to you all. You are the future asset of Pakistan. I do hope that these people will use you. We are very proud of you and really look up to you guys. Thank you very much, folks. My deep appreciation to you.
Thank you.
Thank you.
We'll get those. Thank you.